Hi guys, welcome back to our channel. So today we are continuing with class 10 NCERT chapter 8 exercise 8.1 part 2. We are starting with question 7. Question 1 to 6 are already uploaded on our question 7. We are given that cot theta is equals to 7 by 8 and we have to evaluate these two parts. So let's start with what we are given with. We are given that cot theta is equals to 7 by 8. We also know that cot theta is equals to base upon perpendicular. Now let's start with first part. We are given 1 plus sine theta into 1 minus sine theta upon 1 plus cos theta into 1 minus cos theta. We see that the terms are similar. We can write these as 1 square minus sine square theta upon 1 square minus cos square theta. How? Because we know a plus b into a minus b is equals to a square minus b square. In the numerator, we have 1 plus sine theta into 1 minus sine theta, that is 1 square minus sine square theta, where a is 1 and b is sine theta. In the denominator, we have 1 plus cos theta into 1 minus cos theta, that is a is 1 and b is cos theta. Now, square of 1 is 1 only. So, this is going to be 1 minus sine square theta upon 1 minus cos square theta. Right? Now, we know that cos square theta plus sine square theta is equals to 1. Right? From here, I can say that 1 minus sine square theta will be nothing but cos square theta. Right? Or we can also say that 1 minus cos square theta will be equal to sine square theta. So putting these values in our question, we get 1 minus sine square theta is equals to cos square theta and 1 minus cos square theta is equals to sine square theta. Now cos theta by sine theta is nothing by cot theta, and here we have is cos square theta by sine square theta, so we can write this as cot square theta. Right? Now solving cot square theta, we know the value of cot theta is 7 by 8. So 7 by 8 whole square. Why? Because we have cot square theta here. So square of 7 is 49 and square of 8 is 64, and that is our answer for first part. Now moving to second part, we need to find cot square theta again. So we have the value of cot theta, which is 7 by 8, and we need to square this because we need to find cot square theta. So square of 7 is 49 and square of 8 is 64. This is our answer for second part. Let's move to question 8 now. We are given that 3 cot A is equals to 4 and we have to check whether LHS is equal to RHS or not. Right? So firstly, let's write what we are given with. We are given that 3 cot A is equals to 4. So that implies that cot A is equals to 4 by 3. We also know that cot A is base by perpendicular, right? Now, we know what is the base and perpendicular. So, using Pythagoras theorem, we can calculate the hypotenuse. Hypotenuse square is equals to base square plus perpendicular square. So, base is 4 and perpendicular is 3. So, we get 16 plus 9 is equals to 25. H square is equals to 25. We can write 25 as 5 square. So, hypotenuse come as to 5. Okay. Now, we need to check whether this term is equals to this term or not. So, let's start with LHS first. To find LHS, we need to know the value of tan A, and we very well know that tan A is just the reciprocal of cot A. So, tan A is equals to 1 by cot A, and here we have the value of cot A, which is 4 by 3. So, tan A is equals to 1 by 4 by 3. And we also know that A upon B by C is equals to A by B into C. That is, the reciprocal of denominator gets multiplied with numerator. So here we get it as 3 by 4. Okay. So let's put the value of tan A in the LHS. We have is 1 minus tan square A upon 1 plus tan square A. right? So tan A is 3 by 4. So 1 minus 3 by 4 whole square upon 1 plus 3 by 4 whole square. Square of 3 is 9 and square of 4 is 16. So 1 minus 9 by 16 upon 1 plus 9 by 16. Taking the LCM, we get 16 minus 9 by 16 upon 16 plus 9 by 16. We get 7 by 16 upon 16 plus 9 would be 25 by 16. So we can write this as 7 by 16 is equal to 16 by 25. How? Because A by B upon C by D is equals to A by B into D by C. Again, that is the reciprocal of denominator gets multiplied by denominator. Sorry, the reciprocal of denominator gets multiplied by the numerator. So 16 gets cancelled, we get it 7 by 25. This is our LHS. Now let's calculate the RHS. For RHS, we need the values of cos A and sin A. Now cos A is equals to base by hypotenuse. We have the value of cot A is equals to 4 by 3, which is base perpendicular, and hypotenuse we calculated as 5. So 5 is our hypotenuse and base is our 4. Similarly, sin A is equals to perpendicular by hypotenuse. So hypotenuse is 5 and perpendicular is 3. Now let's put the values. We need to find cos square A minus sin square A. Right? So cos A is 4 by 5 whole square minus 3 by 5 whole square. From here we get 16 by 25 minus 9 by 25. Taking the LCM, we get 16 minus 9 upon 25, which gives us 7 by 25, which is equals to RHS. If we come to question number 9, we are given in a triangle ABC, right angle at B. If tan A is equals to 1 by root 3, we need to find the values of these. So let's firstly draw the triangle. We have this triangle here. We know that it's right angle at B. So this is B. It could be A and C. Right. Now we are given that tan A is equals to 1 by root 3. Right. We also know that tan A is equals to perpendicular by base. Right. We are given tan in terms of angle A. So let's consider this. Now when we are considering angle A, the side opposite to angle, which is BC, would be a perpendicular. Just a second. Would be our perpendicular. This side is going to be a base and this will be our hypotenuse. So we are given that perpendicular is 1, base is root 3. So using Pythagoras theorem, we can calculate hypotenuse, which is h square is equals to perpendicular square plus b square. Perpendicular is nothing but 1 square and base is root 3 whole square. So we get it as 1 plus 3 equals to 4. So h could be 2. Okay, so our hypotenuse is 2. Now we need to find in terms of angle A and angle C both. So let's find in terms of angle A first. Let's find sin A first. Right? Let's find sin A. Sin A is perpendicular by hypotenuse. So perpendicular is BC and our hypotenuse is AC. So it's going to be 1 by 2. Right? Next, cos A is base by hypotenuse. So our base is AB and our hypotenuse is AC. So we get it as root 3 by 2. Now to solve in terms of C, we need to find again sin C and cos C. It's still going to be perpendicular by hypotenuse and base by hypotenuse, but the sides would change now because we are calculating in terms of C. So when angle C is considered, the side opposite to angle C is AB and that is going to be a perpendicular now. Side BC is going to be base and AC is going to be hypotenuse. Now sin C is perpendicular by hypotenuse, that is AB by AC, which is equals to root 3 by 2. Cos C would be based by cos C is based by hypotenuse. Our base is BC and hypotenuse is AC. So it comes up to be 1 by 2. Now let's calculate what we are asked in the question. So let's start with part 1 now. We are given with sin A cos C plus cos A into sin C. Right? So sin A we have calculated here as 1 by 2 and cos C is also 1 by 2. Cos A is root 3 by 2 and sin C is also root 3 by 2. Solving this we get 1 by 4 into 3 by 4. Why a same value gets multiplied in a root, we get the value itself. So it gives us taking the LCM, we get it as 1 plus 3 is equals to 4 by 4 equals to 1. Moving on to second part, we have cos A cos C minus sin A sin C. Right. So cos A is root 3 by 2 and cos C is 1 by 2 minus sin A is 1 by 2 and sin C is root 3 by 2. Both the terms are equal with opposite signs, so answer comes to be 0. Coming to question number 10, we are given in a triangle PQR, right angled at Q, we are given PR plus QR is equals to 25 cm and PQ as 5 cm. We need to determine the values of sin P, cos P and tan P. Let's start with what we are given first. Let's draw the triangle. It's right angled at Q. So it's Q, 90 degree, P, R. Right? Now we're given PQ is 5 cm. So this is 5 cm and PR plus QR is 25 cm. To determine the values of these, we firstly need to find QR and PR. That is, we know according to the Pythagoras theorem, hypotenuse square is equals to base square plus perpendicular square. Right? So our hypotenuse is nothing but PR whole square, base is QR whole square, then perpendicular is PQ, so PQ whole square. Now we are given the value of PQ which is 5, let's put that value in it. So PR whole square is equals to QR whole square plus 25. Taking QR to this side we get PR whole square minus QR whole square plus 20 is equals to 25. Now using A square minus B square is equals to A plus B into A minus B, I can write LHS as PR plus QR into PR minus QR is equals to 25. I am given PR plus QR is equals to 25 centimeters. So I can write this as 25 and this as it is PR minus QR is equals to 29. So 25 gets cancelled on both sides and I get PR minus QR is equals to 1. Equation 1. And we are also given that PR plus QR is equals to 25. Adding equation 1 and 2, I get, what will I get is QR is going to get cancelled with each other because they are of opposite sign. I will get 2PR is equals to 26. So PR is equals to 26 by 2 which is equals to 13. Right? So PR is 13. PR comes to be 13. Now putting this value in either of the equation 1 or 2, I will get the value of QR. So putting value of PR in equation 1, I get 13 minus QR is equals to 1. So 13 minus 1 is equals to QR, that implies QR is equals to 12. Easy? Now we need to find in terms of angle P. This is a P, so this is gonna be a perpendicular, this is gonna be our base and this is gonna be our hypotenuse. Why? because the side opposite to the angle we need to find or consider is perpendicular. So firstly, sine P is equals to perpendicular by hypotenuse. So perpendicular is QR and hypotenuse is PR, right? So it gives us QR by PR is 12 by 13. Now cos P is equals to base by hypotenuse. So our base is PQ and our hypotenuse is PR. PQ is 5 and PR is 13. So cos P is 5 by 13. Now similarly tan P is perpendicular by base. So our perpendicular is QR and our base is PQ. QR is equals to 12 and PQ is equals to 5. So our answer is 12 by 5. Now, in the last question of the exercise, we need to state whether the following statements are true or false, and we also need to justify. In the first part, we are asked that the value of tan A is always less than 1. So, let's understand with the help of an example. So, let's consider a right angle triangle ABC. Consider the perpendicular as 3, base as 4. So, using the Pythagoras theorem, which is equals to perpendicular square plus base square is equals to 4 square plus 3 square is equals to 16 plus 9, 25. H comes out to be 5. We can get the hypotenuse as 5, right? Now, tan A is equals to perpendicular by base. So, here our perpendicular is BC and our base is AB. So, what we get it as 3 by 4, which is less than 1. But say consider we are calculating tan A in the case of B A 90 degree, where the perpendicular is 4 and the base is 3. So hypotenuse will still remain 5. So here tan A would be same, that BC by AB, but it is going to be 4 by 3, which is greater than 1. So we cannot say that the value of tan is always less than 1. It can also be greater than 1, because we can see we just got the answer which is contradictory to a statement asked. So the answer for this question is false. Moving on to second part, we are given secant A is equals to 12 by 5 for some value of angle A. Let's draw this B, C and A. Right? Now secant A is equals to hypotenuse by base, that is 12 by 5. So we are given that hypotenuse is 12 and base is 5. So using Pythagoras theorem, we can get the value of the perpendicular. So if the value of the perpendicular is less than the hypotenuse, we can say this is true, because hypotenuse is the longest side of a triangle. So let's calculate the BC, like perpendicular first. So using Pythagoras theorem, hypotenuse square is equals to perpendicular square plus base square. So hypotenuse is AC. AC square is equals to perpendicular square, which is BC whole square, plus base square, which is AB whole square. AC is 12. So 12 square is equals to BC whole square plus AB square, which is 5. So I get it as 144 is equals to BC whole square plus 25. So from here I get that BC whole square is equals to 144 minus 25, which is 119. So BC comes out to be under root 119. So that is less than the hypotenuse. So we can say that this is true for some angle A. Okay. Now in the third part, they are asking that cos A is the abbreviation used for cosecant of angle A. Firstly, abbreviation is nothing but short form. Abbreviation word is used to describe short form of something. So it is saying that cos A is the abbreviation used for cosecant of angle A, and that is false, because cos A is abbreviation of cosine A, and cosecant abbreviation is cosec A. Okay. Now moving to fourth part, they are saying that cot A is the product of cot and A. This is also false, because cot A is a single term and it is not a product of any two terms, because cot A is a single term. Now, fifth part says then sine theta is equals to 4 by 3 for some angle theta. Now, sine theta is equals to perpendicular by hypotenuse, and we are given the values as 4 by 3. So, it is clearly false because hypotenuse is the longest side in a triangle, and here we see that the perpendicular is greater than hypotenuse, which is not possible because hypotenuse should be the longest side in a triangle. Thank you for watching, guys. We will be coming with more videos super soon.